Our parabola opens to the right with its vertex at the origin. First, I want to find where it will exceed the y-coordinate of this sawtooth pattern that varies between plus or minus 1. So we'll solve for y, and I want to keep y less than 1. This is equivalent to having the lower part of the arc where y is negative x over root 34 is greater than negative 1. So we'll solve for x and square both sides. So right when x is equal to 34, the value of our parabola will go beyond the bounds of this sawtooth pattern. Let's take a look at the part of this sawtooth pattern with positive slope, and we'll just sketch the increasing parts of this graph. The first part is when x goes from negative 1 to 1. The next part goes from 3 to 5. This next section is between 7 and 9. Let's see what happens here in the neighborhood where x is equal to 34. These blue lines are intersecting the x-axis at multiples of 4. So this last one will intersect where x is equal to 32. The equation for this first blue line is y equals x. This one is y equals x minus 4. On this interval between 7 and 9, it's y equals x minus 8. On our last interval, the equation is x minus 32. To generalize, all of these equations look like x minus 4k, where k is one of these integers between 0 and 8. So we have a total of 9 of these upward sloping line segments. Let's take a look at the sawtooth pattern that slopes downward. The first downward sloping part is between 1 and 3, and the next is between 5 and 7. Then we have between 9 and 11. Let's see what happens in the neighborhood of x equals 34. These intervals are 4 apart, and they intersect the x-axis at even numbers that are not multiples of 4. So the last intersection happens at x equals 34. The sawtooth would continue in the interval between 33 and 35, but beyond 34, our parabola will exceed 1 and negative 1, and there won't be any intersecting points. The equation for this first segment on the interval between 1 and 3 is negative x plus 2. On this interval, the equation for this segment is negative x plus 6, and here we have y as negative x plus 10, until we get to this last interval, negative x plus 34. To generalize, we always have minus x, and then we're adding 2 more than a multiple of 4. So I'll write this as 4k plus 2. We fully get these segments when k is between 0 and 7. And then we just get the first part here when k is equal to 8. Let's return to case 1 and count the intersecting points with our parabola. The equation for our upward sloping lines looked like this. The problem asks to find the sum of the y-coordinates, so we'll substitute for x. Solving this for x, we get y plus 4k. This is a quadratic, so we'll gather all the terms on one side. Let's divide by this coefficient because we're going to use v-etas. The two solutions here for y are going to be the roots of the quadratic, and the sum of the roots is the negative coefficient of y, so that's 1 over 34. This is repeated for all these values of k from 0 to 8, and it's true for all 9 values of k. So the sum of the y-coordinates in case 1 is 9 times 1 over 34. Now let's go to case 2. This was the downward sloping part of our sawtooth pattern. We'll solve for x and set it equal to 34y squared, and collect all the terms on one side. Divide by 34 so we can use v-etas. Again, the sum of the roots is the negative coefficient of y. We'll get these pairs of solutions for the first 8 values of k from 0 to 7, and then we just need the positive solution when k is equal to 8. So let's rewrite this quadratic where k is equal to 8. This constant becomes minus 34. Let's calculate the discriminant separately, and then we'll use the quadratic formula. Multiplying this out, we see we get a number that's a multiple of 25. Now we'll solve for y with the quadratic formula. That's negative 1 plus or minus 5 root 185 over 2a. We're only interested in the part of this interval that's above the x-axis. So y is greater than 0. We'll take the positive solution. So the sum of our solutions from case 2, we have 8 solutions that sum to negative 1 over 34 plus this one more solution. Now we'll find the sum of of the y-coordinates from cases 1 and 2. From case 1, we have 9 sums of 1 over 34. From case 2, we have 8 sums that are minus 1 over 34, and then this last intersecting point. We'll find a common denominator and add the fractions. The problem asks for the sum of A, B, C, and D, and our answer is 259. If you'd like me to solve any other math contest problems, please leave them in the comments.